8.3. We are now awesome at trigonometry, and we're going to start using trigonometry to solve right triangles. So by the end of the lesson today, you should be able to use trig ratios to find angle measures in right triangles and to solve real-world problems. So far we found side lengths. Now we're going to actually find angle measures. So before we can do that, let's see if you can do answer number 1, 3, and 4. And if you're not sure how to do 1, 3, and 4, maybe go back and watch 8.2 video. Okay, so the first type of question they're going to give you is kind of a funny question. It says use the trig ratio cosine of A equals 24 over 25 to determine which angle of the triangle is angle A. So we want to figure out which angle is angle A, and I'll give you a hint. It's usually not going to be the right angle. So either this one's going to be angle A or angle 2 is going to be angle A. So what we're trying to figure out is angle 1 angle A or is angle 2 angle A? And they give us the trig function, and that's going to trig ratio, and that's going to really help us. Cosine of an angle, theta, we use theta for angle. Cosine of an angle is the equivalent of, let's see, so, ta, toa. So cosine is always adjacent over hypotenuse. So what we're going to do is we're going to look at, well, okay, if theta is angle 1, which side would be adjacent? Well, that would be 1.4. So I'm going to say cosine of angle 1. I'll put a little angle mark, angle 1. Well, that would be 1.4 over the hypotenuse, which is 5. If it was angle 2, so cosine of angle 2, that would be, well, the adjacent side this time would be 4.8. And the hypotenuse is the same, still 5. So let's look at what those decimals are. So 1.4 divided by 5 is 0.28. 4.8 divided by 5 is 0.96. Notice I'm not hitting the cosine or the sine or the tan button. All I'm doing is putting this in my calculator and this in my calculator. And the last thing you need to do is put this in your calculator. They told you that the ratio of those sides is 24 to 25. So 24 divided by 25 is 0.96. So that means angle A is angle 2. So you can say angle A is angle 2. Done. Okay, so we're going to use these, the ratio of the sides to figure out where to place the A. Another example. Use the given trig ratio to determine which of the angle is A, and you can't just arbitrarily put it. I'll do this one, and then this will be question number 1 on your notes for you guys to try to do. So sine of A. Well, sine stands for opposite over hypotenuse. So I know it's going to be sine of 1 is going to be, well, the opposite side is 27, and the hypotenuse is 30.6. If I wanted to see if it was angle 2, is going to be, I'm going to put an angle because it looks weird to me. Okay, so sine of angle 2, this time the opposite side is 14.4 over the hypotenuse, which is still 30.6. And we want it to be 8 over 17. So you're going to pop those 3 into your calculator. 27 divided by 30.6 is 0.88. 14.4 divided by 30.6 is 0.47. And 8 divided by 17 is 0.47. So what that means is that angle 2, again, is angle A. So angle A has to be here in order for this trig function to work. So again, you try number 1. This will be question number 1 on your notes. Try it, and we'll check it in class tomorrow. That's the first thing you guys are doing in this section. Let's see. The second thing you guys are doing, let's see. We learned in last section that sine 30 degrees equals 0.5. So what that means is, thank you. When we had a 30, 60, 90 triangle, this one's 30. It was, our ratios were always x, 2x, x radical 3, because this is special right triangles, and we're going to keep talking about them. If we wanted to do the sine, that would be opposite over hypotenuse. So x over 2x. These reduce down, and you're left with the sine of 30 degrees is always 1/2, or 0.5. So what happens is, if I tell you that if we get 0.5 for a sine, then that means that the angle has to be 30 degrees. You can't get 0.5 anywhere else. So if you know that the sine of an acute angle is 0.5, you know that the angle has to be 30 degrees. So we're going to use the reverse of what we've been doing to find angle measures today. And we use inverse trig functions to do that. So write down in your notes, we use inverse trig functions to find angles, not sides, angles. And this means inverse. So if you put in the inverse of 1/2 or 0.5 into your calculator, you should get 30 degrees. If you don't, come talk to me about your calculator. Okay, so we're going to, here's an example of how you can do that. Usually if you have the cosine button on your calculator, above it you'll see cosine -1. So you usually have to hit like a blue button or a shift button or whatever and then hit cosine, and that's how you can get cosine -1. So punch these into your calculators and make sure you get these answers. If not, let me see your calculator. Okay. So we use inverse trig functions to find angle measures, not side lengths. Angle measures. Okay. So when I ask you to solve a triangle, that means to find every single thing you can figure out about that right triangle, including angles and side lengths. So if you wanted to figure out what side length ST is, oops, not highlighting anymore. If you wanted to find out what side length ST is, we don't have any angle measures, so you can just revert back to Pythagorean theorem. So I could call this A if I wanted to. A squared plus B squared equals C squared, and I could have A squared plus 5 squared equals 5.7 squared. And then really quickly, I get that answer is 2.7. So I'm going to say ST equals 2.7 to the nearest degree. Oh, nearest hundredth, sorry, 2.74. So that's one answer. Now, we need to figure out still what angle T is and what angle R is. So the second thing we need to do, angle T. Since we're trying to find an angle, we're going to use inverse trig functions, and I'll show you what that means. Now, even though we know what ST is, I still only want you to look at the information given to you in the problem, because we rounded here. So if we round here and then use it in a different question, in a different part, we're going to get an even more wrong answer because we rounded at the beginning. So use these two numbers, it'll be more accurate. So for angle T, we have the opposite side and we have the hypotenuse. So we're going to use sine. Sine of angle T equals opposite over hypotenuse. This is kind of like what we were doing in yesterday's work, except now we don't know what the angle is and we want to get the angle by itself. You can't divide by sine, but you can do the inverse of sine. So to get angle T by itself, you have to do inverse sine of 5 over 5.7. And you just pop this into your calculator. And you should get 61 degrees. Yeah, nearest degree. So angle T equals 61 degrees. If you don't get 61 degrees in your calculator, again, we'll talk about it tomorrow. So now that we know that this is 61 degrees, all you have to do to find out what angle R is take 90 and subtract it from 61. And you'll get 29 degrees for angle R. You could use trig again if you really, really want to because you like it so much, or you can just use the triangle sum theorem. So add them up, subtract them from 180, pretty much. Okay, so one more question. You guys are going to do this one, title this one number 2 on your notes. Solve this problem, we will look at it in class. The last thing that we're going to do is we are going to apply it to the real world. Whenever you see something like percent grade or something about steepness, or has a 31.5% grade, that's telling you how much a road or a stair or something is rising and running. So a 31.5% grade means that the road is rising 31.5 feet for every 100 feet that it goes. So you can think of it like slope. So this is the equivalent of something that has a 31.5% steepness. So in San Francisco, I've only been there a couple times, but I remember the streets being really steep. And it has a road that rises 31.5 feet for every 100 feet. That's pretty significant. So we're going to talk about percent grade and equate it to angle measures. So, for example, a highway sign warns that the section of a road ahead has a 7% grade. To the nearest degree, what angle does the line make with the horizontal line? So again, 7% means that it's going to rise 7 feet for every 100 feet of horizontal distance. So if you drew it as a picture, here's our picture. It's going to go up 7 feet for every 100 feet that has gone. And we want to figure out what this angle right here is. So I'll call that theta. Well, what trig function talks about the opposite side and the adjacent side? Well, that's tangent. So we're going to say tan theta, tan of whatever angle it is, which we're solving for, is 7 over 100. And since we're solving for an angle, that means we have to use the inverse functions. So we're going to use inverse of tan and put this into our calculator, and it is a 4% angle. I'm sorry, I don't know why I said 4-degree angle. So this angle right here that makes a 7% grade is really a tiny, tiny 4-degree angle. Okay. Let's see. So this is number 3. Same thing you guys were just doing. This is the last question that you're going to do on your own. And I want you to do number 3. And then your reflection questions that you're going to answer, I want you to think, what do we use inverse trig functions for, to solve for, and then also how can we use it in real life. All right, enjoy.